There was a time when every photograph told its story in shades of black and white. The old albums lying on our shelves, pictures of our grandparents, the early days of cities, the historic moments of past carry a certain nostalgia. Yet something always feels missing. You can sense the emotion, the setting, the moment, but not the colors that once filled them. What if we could bring those memories back to life again? What if artificial intelligence can paint the past? That's where our story begins. Imagine opening your computer and feeding a black and white photograph into a program. In just a few seconds, you watch as the AI carefully studies every pixel and every edge, every texture, and then, like an artist, pick up a brush and begins adding color. The gray sky turns soft blue, the faded grass becomes a bright green, and the faces of people long gone regain the warmth of skin tones. What once looked like a frozen in time feels alive again. This is not a trick of filters or Photoshop. Behind this magical transformation lies deep learning, a branch of artificial intelligence that teaches machine to understand the world the way humans do. In our project, we use a pre-trained colorization model built on neural network. The model, trained on thousands of real-world color images, learns the relationship between brightness, texture, and color. When it sees a new black and white image, it predicts what missing colors should be, pixel by pixel. The result is a natural, realistic color image, one that feels like never it was ever black and white to begin with. But this project is not just about algorithms and code, it's about emotion. Think of the smile of someone's face when they see a 100-year-old family portrait reworn in color, or a student bringing history to life through old wartime photographs. AI is not replacing art here, it's storing memories that were once trapped in grayscale. Technically, the process involves using OpenCV's deep neural network module with the model trained on the ImageNet dataset. The system takes the L lightness channel from the lab color space and predicts the A and B channels, which carry color information. When combined, they recreate a full color image. In this project, we integrate this model into a chatbot style Python application that interacts with the user directly in the terminal. You simply provide an image path, and the chatbot guides you through the transformation, friendly, simple, and interactive. Open app.py and write the following code. Import numpy as np loads the numpy, the standard library for numerical arrays in Python. Images are handled in numpy arrays. Import cv2 imports the OpenCV computer vision library for image I/O and preprocessing. From cv2 import DNN imports the DNN submodule of OpenCV used to load and run the deep learning models. Here we use the Caffe colorization model. Import OS operating system utilities like file path checks, building paths, model file paths, protofile, model file, hull PTS. These three strings points to the model files required by the OpenCV colorization model. Dot prototext refers to the network architecture definition, the Caffe format. Dot Caffe model refers to the learned weights that it holds. PTS in hull.npy refers to the cluster center points required to bias the network's output colorization distribution. The code assumes that these files are in models folder relative to where the script runs. We will output the code in chatbot style, so we write the following code as chatbot print message small helper to print the message prefixed with chatbot to give you a terminal output as chatbot loop. User input message wrap the prompts user with you consistent stylistic input prompts. Dev man chatbot print hi, I am your image colorization assistant. Chatbot prints I can convert your black and white images to color. This defines the main function and prints two friendly chatbot style welcome lines. Image path equal to user input asks the user to enter the file path. Image path strips the remove surrounding white space. Strip removes the accidental surrounding double quotes common with copying paths and replaces the converts backslashes to forward slashes to avoid Python escape issues and standardized path. OS.path exists checks whether the given image file exists. If not, prints an error and exits the function early and then returns. Chatbot print loading the pre-trained colorization model notifies the user that the model is loading. DNN.readNet from Caffe protofile model file loads the Caffe model into OpenCV DNN module and returns a net object you can run interface with. Kernel equals to np.load hull pts refers to the load pts in hull.npy file numeric cluster centers used later to set the layer blobs. Read and preprocess image. CV2.imRead image path reads the image into a NumPy array in BGR color order, OpenCV's default. If the file is not readable, image will be none. Scaled equal to image dot as type float32 divided by 255 converts the pixel values from unit 8 0 to 55 to float 32 scale to 0 1. This normalization is needed before color space transforms and neural networks input. Lab image equal to cv2.cvt color scales the color bgr to lab, converts the normalized bgr images to lab color space. L refers to lightness, ab refers to the color channels. The model works by predicting a and b channels from the L channel. Add cluster centers. The OpenCV colorization model expects the cluster centers and a rebalancing constant to be set as layer blobs to runtime. This is how the original Caffe model was used. Get layered ID class 8AB, get layered ID conv 8313, find the internal layer IDs by name. PTS equal to kernel dot transpose dot reshape 2 comma 313 comma 1 comma 1 transforms the PTS in hull.npy shape to the expected shape 2 comma 313 comma 1 comma 1. The 313 color cluster centers each with two values a and b. Net dot get layer class 8 dot blobs equal to pts dot as type float 32 assigns the cluster centers to class 8 ab layer. Net dot get layer conv 8 dot blobs equal to np dot full 1 comma 3 1 comma 3 and d type equals to float 32 assigns a constant array to another layer used by the model. This helps scale the output distribution. It's part of the original model's post processing. Resizing the network. Resized equal to cv2.resize lab image 224, 224. The Caffe model expects an L channel input at a resolution of 224 into 224. It was trained that way. So we resize the model string and expand the lab image to 224 into 224. L equals to cv2 dot split resize 0. Extract the first channel lightness from the resized lab image. L minus equal to 50 performs mean centering of the L channel subtracting 50. This is the model specific preprocessing that matches how the model was trained. Chatbot print informs the user that interface is starting. cv2.dnn.blob from image L creates a DNN blob from the single channel L image, formats it into the shape and type DNN expects. Net.set input and net.forward feed the L channel into the network and run a forward pass to predict the AB channels. Net.forward and transpose 1 to 0. Net forward returns the 4D blob. We take the first and only the batch returns the transpose access to get a h, w, 2 array where the two channels are A and B. AB channel equal to cv2 dot resize AB channels. Resize the predicted AB channels to the original image width and height so they can be combined with original L channel. Recombine channels. L equal to cv2 dot split lab image takes the original full image L channel from the lab image we computed earlier, not the resized L used for the network. Np dot concatenate refers to take the original L as single channel and the predicted AB channels to form a full lab image of shape h, w, 3. cv2 dot color CVT color, colorize the CV2 dot color lab to BGR, convert the lab image back to BGR color shape. NP dot clip colorized, 0, 1 ensures the float value are within 0 and 1 numerical safety. 225 into colorized as type unit 8 scale back to 0 to 55 range and converts to unit 8 so it can be saved and displayed. Saves the output. Output equals to path colorized output.jpg. Sets the output path to the file name where the colorized result will be saved. cv2.imWrite output path colorized writes the colorized image to disk as jpg file and the chatbot print done your image has been colorized successfully. Then chatbot prints output saved output as output path, a friendly completion message telling the user that the result is saved. This is optional, but you can show images side by side. Ask the user whether they want a visual preview. If yes, resize both original and colorized to 400 into 400 for a neat preview. cv2.hognate image resize horizontally concatenates the two images so you can see input versus output side by side. cv2.imShow opens an OpenCV window to display the result. cv2.wait key 0 waits for any press key. cv2 destroy all windows destroys the OpenCV display windows. If user says no, print a skip message. If name equal to main. This is the standard Python entry point guard. If the script is run directly, Python app.py called main. If imported as a module, main will not execute automatically.